So where can we get control data for the partials? Perhaps the most obvious source of control data would be the musical instrument itself. For example, if we perform a spectral analysis of a real instrument using the short-time Fourier transform, this gives us the spectral behavior more or less at each point in time as the signal unfolds. We can then track each of the individual partials and then approximate using straight line segments. Here's an illustration of this technique applied to a short burst on a trumpet. I'm indicating the frequency and amplitude trajectories, and then I can, by use of this slider, add or subtract partials to build up the sound. This is only with the first partial, and we can see the corresponding amplitude of our time domain signal quite nicely. Here we see that the frequency has a little bit of a jump at the beginning transient, but it's mostly the same frequency throughout. So now I'm adding the next partial. It's at a higher frequency. This is the next one yet, even higher frequency. And as you look at the amplitude, you notice that the onset of the higher frequency partial is a little bit delayed. So again, you see each of these higher frequency partials has a little bit of a late entrance, but then they also decay faster as well. Somewhere in this area of only a few partials, you can think of this as being somewhat what like a muted trumpet sounds like. And so apparently one of the functions of a mute, besides lowering the overall amplitude, is to reduce some of that high frequency content. So again, as you consider the spectrogram, you can also get that idea of how the higher frequency partials tend to leave the sound earlier than the lower frequency versions.